Hello students, this is second video of linear convolution. In the previous video of linear convolution, we have seen two types of methods to calculate the linear convolution of two sequences. One was formula method and the other was tabulation method. And I have already told you that tabulation method is not to be right in the exam. It is just for the checking of the answer, whether the answer you have calculated is correct or not. So the third type of method is a graphical method. So today we will see the same question with the help of graphical method. Graphical method, as the name says, is by drawing the graphs of the given sequence. So let us say you have two sequences x1n and x2n. x1n is 1 2 3 1 having 4 elements, x2n is 2 3 1 1 also having 4 elements. So the formula for convolution, which is y of n is equals to summation k is equals to minus infinity to infinity x1 of k, x2 of n minus k. This is the formula which we have already discussed in the previous video. So now always we will calculate the starting point. The starting point of the output would be x of n1 plus x of n2, which is 0 plus 0 is equals to 0. This I have already explained in the previous video. If any arrow is given, then arrow indicates the zeroth sample, and if the downward arrow is not given, then the first sample is the zeroth sample. So that is why the starting point would be 0. And then the length of the output. So it will be calculated by n is equal to n1 plus n2 minus 1, where n1 and n2 are the length of the sequences. First sequence and the second sequence. So both the sequences are having length 4. So 4 plus 4, 8 minus 1 will be 7. So that means we have to calculate the output for 7 values starting from 0 till 6. So y0, y1 till y6. So now y0 is equals to, if you put n is equals to 0 in this formula, it will become x1 of k, x2 of minus k. That means x2 of k is folded. Folding shifting we have already discussed in our previous videos. Now y1, that means you are putting n is equals to 1, so it will become x1 of k, x2 of 1 minus k. So that means after folding you are delaying the x2k by 1 sample. Then y2 will be x1k, x2 of 2 minus k. Now what we are doing is we are putting the different values of n in this formula. So if n is equal to 2, it will become 2 minus k, n is equal to 3, it will become 3 minus k, and so on. So I have written from y0 to y6 this formula. So this will be minus k, 1 minus k, 2 minus k, 3 minus k, 4 minus k, 5 minus k, and 6 minus k. So that means first you have to fold the x2k, and then you have to delay your x2 minus k by 1 sample in every sequence. So first we will draw x1n, which is 1, 2, 3, 1. That means at n is equal to 0 it is 1, at n is equal to 1 it is 2, at n is equal to 2 it is 3, and n is equal to 3 it is 1. So as per the given value I have drawn this x1 of k. Similarly I will draw x2k, which is 2, 3, 1, 1. So 2, 3, 1 and 1 at 0, 1, 2 and 3. Now you have to fold the sequence. So folding is what? The sample at n is equal to 0 will remain same, and all the positive sample come to the negative side. So that means at n is equal to 0 it is 2, it will remain same. At n is equal to 1 it is 3, so it will be at n is equal to minus 1. At n is equal to 2 and 3 it is 1, so at n is equal to minus 2 and minus 3 it is 1 and 1. So this is x1 of k and this is x2 of minus k. As you can see in y0 both are multiplied. So this sample and this sample will get multiplied with each other. So only common sample is at n is equal to 0. So at n is equal to 0 it is 1, at n is equal to 0 it is 2. So 1 into 2. So it is 2. So the very first value y of 0 comes out to be 2. Now we will delay the x2k by 1 sample. So if you delay it, that means you are moving forward to the right direction, from left to right. So the sample at n is equal to minus 3 now come at n is equal to minus 2, and the values of the yn will remain same. So only thing is you are shifting this sample towards the right side. So at n is equal to minus 2 it is 1, n is equal to minus 1 it is 1, at 0 it is 3, and it is at 1 it is 2. So now you will multiply x2 of 1 minus k with x1 of k. So this and this. How many common samples? At n is equal to 0 and at n is equal to 1. So at n is equal to 0, 1, at n is equal to 0, 3, so 1 into 3, and 1, at n is equal to 1 it is 2, at n is equal to 1 it is 2, so 2 into 2. So 4 plus 3 it is 7. So this way what I have done is, you can see I have displaced my value of x2 of minus k with one sample towards the right side in each value. x2 of 1 minus k, x2 of 2 minus k, 3 minus k, 4 minus k, 5 minus k and 6 minus k. So I have shifted all the values by one sample in the x-axis towards the right side. And what I am doing is, I am multiplying this x1 of k with every value. For y0 I will multiply this with this. For y1 I multiply x1 of k with x2 of 1 minus k. Then y2 x1k into x2 of 2 minus k, x1k into x2 of 3 minus k will give you y3, then y4, y5 and y6. Only thing is, we have to check what are the common values. Like for example, x2 of 6 minus k is at 3, 4, 5, 6, and you have values 0, 1, 2, 3 for x1 of k. So only 3 is common. So at 3 n is equal to 3 it is 1, at n is equal to 3 it is 1, so 1 into 1 is 1. So accordingly I have multiplied all the values, you can see. So finally we have got the answer as 2, 7, 13, 14, 8, 4 and 1. 2, 7, 13, 14, 8, 4 and 1. So this is how the same question can be solved with the help of graphical method. So till now what we have discussed is, we have taken two samples or two sequences with finite duration. As you can see, both the sequences are having finite duration. And we have seen various methods like graphical method, tabulation method as well as formula method. But now what if either of the sequences is infinite or both the sequences are infinite? So let us take two examples, one for both the samples are infinite and one in which one sample is finite and another sample is infinite. So let us see those type of questions also for linear convolution. Let us consider two sequences. One sequence x1n is 1, 2 and 2. That is, it is having only 3 elements. Another sequence x2n is un, which is a unit step function. Unit step function is what? x2 of n is equals to 1 for n is greater than or equal to 0, and it is 0 for n is less than 0. That means if you consider it graphically, it will give the value as 1 from 0 to infinity, and below 0 it is 0. So this is a unit step function which is an infinite function. So the formula for convolution is y of n is equal to summation k is equals to minus infinity to infinity x1k x2 of n minus k, which is if you are considering the first sequence, this which is only from 0 to 2, so it will become k is equals to 0 to 2 x1 of k x2 of n minus k. So now we will expand this, which will be x1 of 0 x2 of n, x1 of 1 x2 of n minus 1 plus x1 of 2 x2 of n minus 2. I have expanded this summation from 0 to 2. So in place of k I have kept 0, 1 and 2. So y of n will be now x1 of 0 is 1, x1 of 1 is 2 and x1 of 2 is also 2. So this will be x1 x2n plus 2 x2 of n minus 1 plus 2 x2 of n minus 2. So now put n is equals to 0. So y0 will be x2 of 0 plus 2 x2 of minus 1 plus 2 x2 of minus 2. As you can see, the unit step function for n is less than 0 it is 0. So for x2 of minus 2 and x2 of minus 1 it is 0, and for x2 of 0 it is 1. So y0 is equals to 1. Similarly, y1 it will be x2 of 1 plus 2 x2 of 0 plus 2 x2 of minus 1. Again this value will be 0 because it is less than 0, and for this and this the value is 1. So this is 1 plus 2 into 1 will be 2, so that is 1 plus 2 is 3. And then y2 will be x2 of 2 plus 2 x2 of 1 plus 2 x2 of 0. So now in this case x2 of 0, x2 of 1 and x2 of 2 all are having value as 1. So this will be 2 plus 2 plus 1, which is 5. Now y3, x2 of 3 plus 2, x2 of 2 plus 2, x2 of 1. So 1 plus 2 plus 2, 5. So now from y2 onwards, every value will give you the value as 5, because this value increases in the positive direction, and you know that for n is greater than or equal to 0, it will give the value as 1 always. So in place of x2 3, x2 2, x2 1, all these values are always 1. So finally you can write your answer as y of n is equal to 1, 3, 5, 5 and dash dash dash. That means all the values now onwards will be 5. So this is how you can calculate the convolution if out of two sequence, one is a finite sequence, another is an infinite sequence. Now finally we will check the third type of convolution in which both the sequences are infinite sequences. So now we will take the question in which both the sequences are infinite sequence. Let us say x1n is equals to un, which is a unit step function, and x2n is equals to a to the power n un. So again the formula for the linear convolution is y of n is equals to summation k is equals to minus infinity to infinity x1 of k, x2 of n minus k. So instead of x1 of k, I will write u of k, and for second function I will write a2 of n minus k, u of n minus k. Now we have to decide the limit of this function, because this function exists from 0 to infinity and this is n minus k. So if you draw unit step function u of k, it exists from 0 to infinity. Now u of minus k is folded unit step function, that means it exists from minus infinity to 0. And u of n minus k means what? U of n minus k means now you are delaying the sequence by n samples towards the positive side. So now this function will exist from minus infinity to n. So u of n minus k exists from minus infinity to n, and u of k exists from 0 to infinity. So if you take the combined or common limit between these two, it will only from 0 to n. So the limit for our function will become k is equals to 0 to n, and then between 0 to n your uk will be 1 and u of n minus k will also be 1. So this is only a to the power n minus k. Now the limit is 0 to n. A to the power n I will keep outside this summation sign, so it will become a to the power n, k is equals to 0 to n, a to the power minus k, right? So now this is a geometrical progression GP series. In mathematics you know this solution for this. If it is in the form of summation n is equal to n1 to n2 a to the power n, the solution for this is a to the power n1, that means the lower limit, minus a to the power n2 plus 1, which is upper limit, upon 1 minus a, where a is not equal to 1. Because if a is equals to 1, 1 minus 1 will become 0, that means it will be infinite. So for the value where a is not equal to 1, this is the mathematical formula for geometrical progression or GP series, which you have studied in class 11th or 12th or maybe in class 10th, I don't remember, wherever. So in this case we have to keep this function in the form of this. So a to the power minus k can be written as a to the power minus 1 to the power k. So now this part will become your a, and then a to the power n, according to this a to the power n1, which is a to the power 0, which is 1, and then a to the power minus 1 to the power n plus 1 upon 1 minus a, which is a inverse. So now a to the power n will be multiplied with this, so it will become a to the power n, a to the power n into a to the power minus n minus 1 upon 1 minus a inverse, which is a to the power n minus a to the power minus 1 upon 1 minus a inverse. Now a to the power n minus 1 upon a upon 1 minus a, then a will be multiplied with this, it will become a to the power n plus 1 minus 1 upon a will come in the denominator. So a into 1 will be a, and a inverse into a will be 1. So this is your solution for infinite sequence. So whenever there are two infinite sequences, two things are more important. One is calculating the limit the way we have calculated the limit through this graphical method, and another thing is the formula for this, which is n is equal to n1 to n2 a to the power n. This is a mathematical formula, you need to remember it. So these two things are important. If these two things are known to you, then you can easily solve such type of questions. So this is a question in which both the sequences are infinite sequence. So in this video we have understood the concept of graphical method of linear convolution. Then we took an example in which one sequence was finite and another sequence of infinite, and in the next example, that means in this example, we have taken both the sequences as infinite sequences. So I hope by watching both the videos, that is my previous video of linear convolution and this video, now you are able to understand the linear convolution properly, and now you can solve the questions in proper manner.